text. And the converting process, you can see it as scrambling the actual message. So imagine you have letters written in a blocks of things like, have you ever played Scramble? No, Scrabble. Scrabble? Do you know a game called Scrabble? This is where you like arrange a word from letters. Yeah, so imagine that you have a letter with a specific order that form a word, and then you mixed up those letters so that you hide the actual meaning of the word. So that's how encryption works. And again, we have a specific module for this. I don't discuss it any further, but for illustration only, let's imagine that you have the secret formula of for Coca-Cola ingredients. And then if you encrypt this message, so this is the plain text, sorry. This is the plain text, and then you encrypt it, and then you will scramble the message. So anyone who doesn't know how it works, so anyone who doesn't know how the encryption works, they won't be able to read the actual message. So you're gonna hide the message by scrambling it. And then you decrypt the message to return the encrypted text or the ciphertext back into the plain text. And this is how we secure the information from man in the middle. So imagine if there's someone in the middle that can read the encrypted message, they wouldn't be able to understand what it means. They just see a bunch of strings that doesn't have any real meaning. So how is it implemented in computer network? Have you ever heard of SSL or TLS? Anyone's heard TLS, SSL? Okay, if you open a website now, does it have or does it start with HTTP or HTTPS? Try to open any website on your computer, Google or Facebook, and then check the URL on the address bar. HTTPS. Do you know what's the difference between HTTPS and HTTP? Yeah, so the S I think stands for secure. So it means HTTPS is more secure than HTTP. And how HTTPS is more secure than HTTP is because with HTTPS, we send the message using secure socket layer or transport layer security. So both are the same things, but secure socket layer is the previous version, is the older version. And then the new version, we call it TLS, transport layer security. So everything that goes into secure socket layer, everything that goes into SSL is encrypted. And this is the way it works. So before sending the message, usually when you did your web server or web browser, you just send the plain text directly to the web server or vice versa. But with SSL, there are some steps that you need to do, like sending client hello, and then the server will reply with server hello. And there's some key exchange happen between the client and the server. And there's some agreement that has to be made about the cyber suit. And then after this four-way handshake is done, then you can send the get and get the response. Well, luckily, we don't have to do this kind of complicated stuff in Java because Java already implement SSL as part of its library. We call it SSL socket. I think some of you did it with the web browser assignment. So if you want to use SSL in your network-based application, you can use this SSL socket instead of just the normal socket. And it's pretty easy. Like you only need to change 2 lines of codes basically. So if I want to transform my web browser to support HTTPS, I just need to change about 2 lines of code. So first, what we need to do is we need to create an SSL socket factory by using this line of code. And then once we're done with the creating the SSL socket factory, we can just create the SSL socket object by calling the create socket method from the socket factory. And if you can see here, the line is pretty much similar. You just need to mention the host and the port. Usually, if you're dealing with HTTPS, the port used is 443. So it's not 80 anymore, but it's 443. What about the data transmission? Because we have to encrypt the data, right? So who does the encryption? Java does it. So there's no change. There's no need to change your code for the data transmissions. So you still use the same input and output stream. You still use the exact write and read method. There's no change needed at all for this part. Okay, to demonstrate this, let's open the NetBeans. Where's my NetBeans? Okay, let's. Okay, anyone at home, can you see the NetBeans now? Okay. Oh, can you see the NetBeans? No? Okay, let's just share the whole screen. What about now? Yeah. Okay, great. Okay, wait. Well, the thing is, I can't see clearly. This is the trouble. Which one is the web browser? One? No, not this one. Okay, I think you need to create a new project. Who did the SSS socket for the? Hang on, I think we've got some feedback. Who did the SSL socket with the first assignment? Oh yeah. Do you want to demonstrate yours, Irwanda? Can you join the Zoom and share a screen maybe? Or actually, if you can send the GitHub link on the chat, I can put it on the screen. Kirim GitHub linknya aja. Kirim GitHub linknya, ya saya yang buka. Okay. There you go. This one. So as you can see, it's similar to what I just explained. Here, first we create the SSL socket factory, get default, and then in this code, it is checked if whether the protocol is HTTP or HTTPS. If the protocol is HTTP, we create a new socket using the usual way. But if the protocol is HTTPS, we create the SSL socket using the socket factory, like this, similar to what I just explained. And as you can see, the requests itself, they're not that different. And the way we process the rest, like using buffered input stream, buffered output stream, they're all the same. So there's no difference for the for exchanging the message. Yeah. So this is the example of using SSL socket factors. So if you want to try with your own web browser, you can do it. Just replace the socket creation with these two lines. So get default and then socket factory dot create socket. So it's the same. And then everything that works with your previous version will work with the new version. Okay, any questions so far? No? Well, if not, let's go back to the slide. Well, that's it for SSL socket. Really, it's pretty much easy. It doesn't need too much effort to convert your code from using socket, the normal socket, to the SSL socket. Okay, so next we have object serialization. Has anyone ever heard of this term before? No? What is an object? Okay. Wait. So what's the date now? 6. COSIM. What is an object? In computer programming, of course. What is your definition of an object? Kenapa? Yeah, sure. Go ahead. Kumpulan data yang digabung jadi satu. Oke. Apalagi yang dimiliki oleh sebuah objek selain data? Ya. Siapa tadi ngomong? Oke. Ya, Irwanda. Sorry, apa? Behavior. Ya, oke, behavior. Ya, tepat sekali. Jadi objek itu adalah kumpulan data dan behavior. Jadi dia punya informasi yang berupa atribut, kemudian dia juga punya bagian lain yang berupa fungsi, ya, yang kita definisikan sebagai fungsi atau behavior, the things that the object does. Okay, so we have an object. We know that an object consists of attributes and behaviors, like functions, and we have something called object serialization that allows us to sending that object through the network. So instead of sending a bunch of text or a bunch of strings, you just send an object. So let's see an example. So in the first example, this is what you usually did with your web browser and web server. You send some strings to the server, and then the server will also reply with a bunch of strings. So you have here the C, for example, the client sends a command called get list, and then the server replies with several lines. So this is an example of what you would send if you made a chat application. So for example, the client sends get list to obtain the list of clients that are online now. And then the server replies with list start, and then it sends the list of clients along with their status, their online status, and the status message. And then it ends with a specific command called list end. This is what you usually do. This is what you usually did with your web client, web browser and web server. But with object serialization, instead of sending a list of strings, we send an object. So we send a bunch of data directly through the network. So for example, here, I have two objects. The first object is sent by the client. So the client sent an object that has two attributes, command and parameters. So the command says get, and then the param says list. And then the server, it will reply with an object that contains an array or a list here. And then the list contains some objects that has the attribute names, status, and the text, the status message. Which one do you think is more convenient? The second one? Yes. Okay, who vote for the second one? Okay, someone's, I think it's like peer pressure. Okay, who vote for the first one? No? Okay, so each approach has their own advantage. So with the second approach, so with the object serialization approach, the parsing method is pretty much easy because it is done by the programming language. So if you're using Java, Java will do the parsing for you. It will parse the object sent through the network, and then it will kind of restructure the object. So it builds the object from a bunch of bytes, and then you can automatically get the information. While the first approach, you usually will do the parsing yourself on your own, just like what you did with the web browser and the web server. And I bet you would say it's painful to do. But the advantage of using the first approach is you can build the program in any language. So it doesn't have the client and the server, or both sides doesn't have to be built using the same programming language. While for the second approach, you have to build the program using the same programming language. So if the client is using Java, the server has to use Java as well. So this approach exists, so object serialization exists in any object-oriented programming language. So Java, Python, although it's fake, C++, C#, they all have object serialization. So let's do some example with object serialization. So if you want to develop an application that sends objects instead of text, these are the steps that you need to do. So first, you need to create a new class for the objects being transmitted. And that class has to implement an interface called serializable. Okay. And then once you create the class, you need to, as usual, you need to create the appropriate socket objects. So if you're building the server-side application, you will need the server socket. And if you want to build the client-side application, you will need the socket object. It's pretty much the same. The only difference is instead of using buffered input and output stream, because we are sending an object, we need to use the object output stream and object input stream. By using this input and output stream, we can send and receive objects instead of binary or text. Okay, So let's go back to the first step. From the previous example, this one, the second approach, the object serialization one, how many class you need to create for this approach? How many class or how many classes that you need to create, or how many classes that need to implement serializable? How many objects are there? How many different objects? Yeah. Yes, correct. So in this example, we need two classes that implement serializable. The first one is the class for the client object. I call this the client object because this is the one that's sent by the client, and it has two attributes, command and parameters. And then the second object or the second class is list. The second class contains a list that has name, status, and tag. Okay, can you just build a class instead of two classes? So instead of developing two classes that implement serializable, can you just develop one class that implements serializable? Okay, who says you can implement this in one class? Okay, how would you do it? Jadi kalau ini kan kita tadi pakai dua kelas. Kita butuh dua kelas. Satu kelas untuk klien, satu kelas untuk server. Pesan dari server dan pesan dari klien kan. Bisa nggak ini kita jadikan jadi satu kelas? Pesannya. Kenapa? Tepat sekali. Jadi bisa. Jawabannya kalau bisa atau tidak? Ya bisa. Jadi kalian bisa membuat ini menjadi satu kelas saja. Jadi atributnya ada perintah, parameter, kemudian ada list. Semuanya dikirim. Cuman seperti tadi yang kalau seperti itu berarti ada bagian-bagian yang kosong yang itu harus dikirimkan. Nah, kenapa itu tidak efisien? Karena kalau kita mengirim objek, meskipun objek atau atributnya itu tidak ada nilainya, itu dia tetap membutuhkan extra space. Dia tetap membutuhkan space tertentu untuk dikirimkan, sehingga kalau objek yang dikirimkan itu besar, atau atributnya itu banyak, dan banyak yang kosong, maka akan banyak space yang terbuang, percuma. Tentunya itu tidak efisien. Oke. I'm gonna go through with the slides first, and then we'll implement this with NetBeans. Okay, so these are the steps that you need to do to develop an app that sends object. First, you need to create a new class or classes, and then you need to create the appropriate socket object, and then you can send and receive objects using object output and input stream. Okay, so how do we create a new class? It's simple. I think you can do it by yourself. So for example, if I want to send an object of a person, I create a new class person that implements serializable. And then I put some attributes here. So for example, I have two attributes, full name and the age. So both have its different, it has its own type. So full name is a string, and then age is an integer. And then I created getter and setter methods. So for example, here I have the, sorry, wrong screen. Get full name, set full name, and then I have get age and set age. And how do we do, how do we send and receive the message? We can look at the next slide. So for sending an object, first you need to obtain the object output stream from the socket. So you can do it like this. It's similar to using buffered input and output stream. So if you want to send an object, obviously you need to create an object output stream, and then you get the output stream from the socket. And then if you want to send an object, wait, I made a mistake here. Okay, we missed something. I will edit this slide later. Anyway, I create the new object that I want to send, and then I fill in the attributes, and then I can just send the object by calling a function or a method called write object. And then don't forget to flush it, because flushing is important. And then to receive an object, again, you just need to create an object input stream. The way to do it is pretty much similar to the one we did in a previous meetings. And then if you want to read the object, you can just call the read object function or method from the object input stream. And then because read object will receive or will return an object, so you need to typecast it. So you need to convert it to the appropriate class. So for example, here, because I know that the objects being transmitted is a person object, so I need to typecast this, or I need to convert this into a person class by using the typecasting code. And then I can just print the object by calling the appropriate methods. It's pretty simple, right? Now let's implement this. Where's my NetBeans? NetBeans. There you go. Okay. So we need to create two applications. Yeah, we need to create the client and the server. I created one already. So you need to create the client object. Let's just delete this and start from beginning. Hang on, I can't see it. Okay, I'm just gonna. Okay, I'm just gonna delete all these objects. Yes. Okay, so it's a clean slate now. Okay, first we need to create the object, and the object needs to be accessed by the client application and the server application. So there are two ways to do it. It's either you write the same object in the client side and in the server side, or you can just create a Java library that will be imported by your client application and server application. So I'm going to pick the second approach because it is much more efficient. So I'm going to create an object, create a new project here. And then I'm going to go with Java with Java, going to pick Java class library. And I'm going to name this project set object. Okay, so here's the chat object source spec package, and then I'm just gonna create a new package first. I'm gonna name it com.chat object. Okay, and then I'm gonna just create a new class. Gonna call it person. Okay, so now I have a person class, and in order or to enable this being sent using object serialization, we need to implement serializable. Okay, so there's one thing that you need to know. If you want to send an object using serializable, all the attributes inside that object have to be serializable too. So not all classes in Java are serializable, but all primitive types like integer, boolean, char, strings, they're all serializable. So it's safe to use all those primitive types. But if you want to use classes, be careful, because if one attribute is not serializable, you won't be able to send that as an object. I'm gonna string. Okay, I'm gonna create two attributes, full name and age. And then I'm just gonna refactor encapsulate field. There you go. Okay. So we just did this. We just created a class that implements serializable. Okay. What's next? The next step is we need to create two sides of application. We need to create the server side and the client side. Let's create the client side first. So I'm going to create a new project, Java with and this time I'm going to create a Java application. gonna okay, so we have the chat client here. And as I said earlier, this chat client needs to import the previous project. It needs to import the person class from the chat object project. So the way to do it is, where's the chat client? If you use different IDE, you may need to do different stuff, but essentially it's the same. So I'm gonna right click on the library and then add project. So here I'm just gonna pick the chat object and I'm gonna add. Okay. So by doing this, every time we change the chat object project, or if we make any changes to the person class, it will update it automatically. Right? So again, we need to create a new socket. That this is localhost, and then put some random numbers. So run statement with try catch. Okay. So now I want my client to send an object to the server. So what I need to do, because I want to send some information, I'm just gonna create object output stream. Then I'm just gonna get the output stream from the socket. Okay. So now I want to send a person object, but first I need to create one too. Okay. So you can see it's imported automatically. And then I can just type set the full name. And then I'm just gonna set the age. Let's say 25. Okay, so we created the object. Now what we need to do is send the object. So we can just type, we can just write object output stream dot write object. Okay, go. So we need to send the person object, and don't forget to flash. And then I'm just gonna close the connection. Let's just make a simple one, a simple project first. Okay, I'll give you some time to type this down. Oh, sorry. Okay, you done? Okay, now after creating the client-side application, we're gonna create the server-side applications. Same as before, we just need to create a Java application. I'll name this chat server. Okay, now I'm gonna just
create a new server socket. Put some random number surround statement with try catch. And there's one thing again that we need to do. Where's the project? There you go. We need to add the chat object project to this project. So just gonna right click, not library, add project, and then I'm gonna pick. So I'm gonna pick the chat object and add it to my current project. Okay, we're good to go, I think. So now I need to listen for the connection, and then again, just gonna accept a new client. Okay, as usual, and then because I'm going to receive the message, I need to create an object input stream. And obtain it from the socket. Okay. Now to read the object, I just need to create a new object, and then just gonna call the read object method. And you can see there are some red lines over there. That means we have to first import, and then we need to pass object to person. So you need, in case you don't remember, any object in Java is a descendant of the class called object, Java lang object. So you can typecast an object to any of its descendants. Okay, we need to add the catch clause in case the class is not found. Normally it is. Okay, and then just gonna print out there, have a go. Okay, where were we? I'm just gonna print the full name of the person, and then just gonna print the age. And as usual, I'm just going to close everything. Okay, I'll give you some time to write this down. Okay. Okay, while typing, just gonna run this. So let's run the socket server. Sorry, the server side. Okay, so it's running and it's waiting for a new client. And then I'm just gonna run the client now. Okay, the client finished successfully. It sent a message. Now let's see what happened in the server. As you can see, on the server side, we receive the object and the attributes of that object. And we can print it, we can work with that attributes. We can also send it back to the client. And there's no need to parse the message anymore. Any questions up to now? Yeah. Okay, do you want to share screen so we can all see the problem? I'm gonna stop sharing first. Okay, I can't see it. Zoom ratio. Ah, there you go. Yeah, let's remove jacket from the screen. Few standard. Okay, that's it. Yeah, so it's a we can try to find the maybe I from maybe you can combine yes, we need to combine that and relate into that. Yeah, the project. The project, and if you go into the you will find the Java somewhere. So I need to re-import the project structure. Oh, I don't speak the moment. Okay. And then that object that you yeah, just and that object expanded out that object. Yeah, okay, and that's maybe. Okay, in NetBeans, it's pretty much easy because it hides all the complexity. But if you're using any other IDE, what you need to do is basically you need to compile the chat object first to obtain the jar file, and then import the jar file into the other project. So if I go to my Yeah, yeah. Okay, let me just start sharing then. Okay, so we have this. Let me show you. Where's this? Where's this located? Pins project documents. Okay. Okay, let me show you the structure. So this is the chat object project, and this is the source. And I think you'll find the jar files somewhere over here. No, this is the class. Should be on this. No, it doesn't create the jar file. Hang on, let me build the thing for you. Chat object, clean and build. Okay, so now I have this chat object.jar. So basically what you need to do is just import this into your chat client and chat server project. That's actually the way to do it. All right, another question. Okay, if not, let's move on a bit, because in the previous meetings, we've learned about how to create a web server applications. But now we're going to make something slightly different. So with the web server, the client usually send a request, and then the response will be sent back to the client itself, the client who requested the request. But sometimes you want to send a message to another client. Like, for example, if you do online gaming, you're gonna need to send the position of your character to the server, and then the server will forward the position of your character to the other players. Or if you want to create a chat application, you will the client will send a message to the server, and then the message will be forwarded to the respective clients or the respective destination. So we're gonna do something like that, a simple one, because spoiler alert, that's the next assignment. Okay, so now we have the server, we have the client, we have the object being sent. Let's say we're gonna I'm just gonna send the person. So here, what do I need to do? Which one do you think I should do first? So I'm gonna make a simple chat application that allows someone to send a message to everyone connected to the server. Okay, let's start from this one. So instead of, I'm just gonna create a new class. So instead of a person class, I'm just gonna create a new class called message, just for the sake of something that easier to understand. Let's create a Java class, call it a message. I'm just gonna use implement serializable. Okay, just gonna put two attributes, that is the sender and the message itself. So just gonna encapsulate the field. Refactor. There you go. Okay, we've done it. And then on the client side, oops, I need to charge. Okay, it's probably best if I record this. So I'm just gonna go a bit quick, and then you can rewatch it at home if you want. Record.
Recording in progress.
Okay. Okay. Okay, shall we take 5-minute breaks and then continue later? Maybe I'll just pause this first.
Recording stopped.
If you want to go to toilet or I don't know, I think most of you fasting today. Okay. Let's get back to this.
Recording in progress.
Okay, we did the message. Now we need to make some modification to the chat client because we're only making a console applications, and unfortunately we have to make multi-threaded application. So I'm just going to create a new class in the chat client for the thread. Java class thread client. Okay, and then just gonna extend thread, and then create run method. Okay, let's fix this one first. So we create a new socket. We need to create the object output and input stream, and then we're gonna need to send the message. Okay, so let's move this part. I'm gonna move the sending part to the, oh, sorry, no, I don't need to move the sending part. I just need to create some lines for accepting inputs. I'm just gonna let's do while true. Okay, let's create buffer reader. Yeah. Okay, then it's gonna print here. Enter your username. This is not the most efficient or the most tidy code at all, so I would recommend you fix this later. But anyway, I'm just gonna show how it works. I'm just gonna read lines. So I'm gonna store the username in the username variable, and then gonna ask them to read. Type your message. Then, similar to before, it's gonna store it in a variable, and then once I did this, read line. So I'm just gonna need to create an object, a message object. Sorry, this one's not. Let's change this to text. So we need to create a message object. Then I'm just gonna set the sender to the username. Then just gonna set the text to text. Once I done this, I'm just gonna write the object to the server. Something like this. So flush. This one is unreachable, so I'm just gonna delete this. Okay, so we can now send the message. What we need to do now is make the client to wait for a new message from the server. So how do we do that? We need first to create a new thread client, and in this thread client, what I need to have is the object input stream. Sorry, it's not public. It's private. And then I'm just going to create a new constructor. That accept an object input stream. Okay, let's wait. Okay, let's get back to this and then set the object input stream to the object input stream. Let's make this an infinite loop. And for each loop, we just need to make the object input stream to read an object. And if there's any, we just print it to the screen. So first, we need to create this object message and obtain this from read object. As usual, we need to cast it to the correct one, and then we need to surround statement with try catch. There you go. Okay, we've got this. Once we receive the object from the server, we just need to print, let's say, message.get sender say something is and then we print the text. So this is our thread, the thread client. So it keeps waiting for any new message and then print it to the screen once there's something. Okay, I think we're done with the chat client. We can send the message. Yeah, we did. Okay. Okay, now let's move on to the server. This is the hard part. Okay, as usual, because this is a multi-client, it is not possible if you don't use multi-threading capabilities. So, where's the chat server? Ah, there you go. Source package. So I'm just gonna create a new class called thread client. Well, I just name it the same, but the functionality is different from the thread client in the client side. So implement thread. Extend thread k public void run, and let's do something about it later. Okay, now we need to create the constructor, and as for the constructor, I need one parameter. I think just need the socket object. And then I will store this in the attribute of the class. So I'm just gonna do this socket equals socket, and then I'm just gonna need the object output trim, and I'm gonna need the object input trim. I'm gonna initialize all of these in the constructor. Output stream, and then this dot then gonna initialize the input stream. This is the socket dot get input stream k run statement with try catch. No, wait. It's the wrong block. There you go. Okay, so now we have the input and output stream. It's pretty much similar to what you did with the web server. And so every time a new client comes up, we create a new thread client object, and then it will wait for any message from the client. Okay. While let's just do while true. Don't do this for your assignment. So usually what I do is I create an attribute that marks whether the client is still connected or not. When it's still connected, I will keep waiting for the message. Otherwise, I'm gonna break the connection and remove my the thread from the server. But for now, let's just do this simple stuff. So what I need to do in this bit is I need the server to listen for any message from the client. So I'm just gonna read an object. And save it. Okay. So what do you think I need to do here? If I receive the message from the client, what should I do? Because in this case, I want my client to be able to send a message to the server, and then it will be distributed to the all clients connected to the server. So it's a broadcast message after all. Okay, what should I need to do here? Just the pseudocode or just a sentence. It doesn't have to be lines of code. But yeah. Sure.
This object that has been gathered from the object.
Can you repeat that again?
From object in the same, I think it will be output and it will send again to the client when using object of the string.
Okay, so we need to send the object we receive from the input stream to the output stream.
Yes.
To the output stream of this client or the other clients.
Or the other client.
Okay, do we have information about the output stream of other clients here? We don't, do we? So we need to let's just type the pseudocode. So send this message to other clients. So how do we do this? This is what I usually do. You don't have to exactly do the same thing, but this is the way I solve this problem usually. So I'm just going to create a new thread object. So instead of just using thread clients, I'm going to create something called thread server. So this is the object that wait for the connection and then maintain the list of clients. So here, let's say I have, sorry, because this is going to be another thread. Just gonna do this extend thread, and then I need to have array list, I think. Should I get array list? Hash. There you go. It's going to use hash table. Type string and thread client. So do you know what the hash table is? So basically, we have a table with a key and value. You can find the specific value using a key. So for example, if I want a specific object of thread client, I can just use a specific string here to refer to that client. So I can use the username basically. And this is much faster rather than iterating all the list of client using, maybe array list or array. Just gonna say this client list, and then just gonna need the server socket, and then just gonna type the constructor is the client list equals new hash table string thread client. Okay. And then I need to initialize server socket. Same as before, change this to 6666. Okay. Surround block. Yes. Now we just need to create what it needs to do, like by implementing or overriding the run method. Okay, let's write down the pseudocode or the algorithm first. What this thread server needs to do. First, it needs to listen for a new connection, right? And then accept a new connection. Okay, when it is accepted, we need to create a new thread client object. Because we want another thread to handle the connection to the client. And then after creating a new client object, we need to start the new thread, and then after starting the new thread, we need to store the new thread to the hash table so that we know the list of clients. Okay. Sounds easy. And then I will create a new function here that calls send to all. So basically what this function does is just send the message to all connected clients. So here I'm just gonna iterate all clients and then send the message. So I'm gonna iterate through all the clients and then send the message, and that's all. So basically what we need to do with the thread client is just call this function to send the message. Okay, now let's implement this. So we need to listen for a new connection. We created that. We need to accept new connection. Don't forget that we need, sorry. While true, again, this is not the proper way to do it. Don't do this. Okay, now we need to accept for a new connection. So this, sorry, socket, new socket, sorry, this dot server dot accept. Okay, now we accept it, and then we need to create a new thread client object. I'm just gonna create a new thread client. And then as a parameter, I give it the socket object. And then of course I need to start the client. And then I need to store the new thread to the hash table. So how do I do that? I'm just gonna create an ID first. I'm gonna use the IP address of the client and the port. So I'm just gonna do this socket.get. Hang on. Client ID. Oh, us. It's really hard to see it from here. Socket dot get internet address dot host address plus Get port. Yes. Okay, so this is the ID of the client that I used to identify the client. And then I'm just gonna add the thread client to the hash table. What's the name again? Client list. Add contains or get, I think push or something like that. Put, there you go. So it's client ID, and then this is the thread client object, and then that's it. Okay. Okay, so now let's save this first. We need to be able to call the send to all message from the thread server. Sorry. We need to be able to send the, we need to be able to call the send to all function of the thread server from the thread client. But the problem here, we don't have any reference to the thread server object, right? So how do we do this? We need to create a new attribute called thread server. And then I'm gonna pass this as the parameter. Then assign it. And then by doing this, now in here, I can just call the send to all message, right? So in here, of course, I need to make some changes. So instead of just giving one parameter, I need to get two parameters, and then I just say this. So that means the current object, the current thread server object is passed onto the thread client, the new thread client object. So now the thread client has the reference of the thread server object once it's running. Now we need to, here we just need to iterate the clients. Okay, let me just Google some stuff to speed these things up. Iterate stable. Okay. So now we have to iterate through all the clients. So there are many ways to do it, and I just Googled some stuff. You know, after many years of coding, I still Google some stuff. Well, this so I'm just gonna use enumeration. There you go. String. This dot hash what's called client list dot keys. So you're gonna obtain the keys which is all the client IDs, all this IP address and port. And then to iterate through all the elements, we just need to call e.hash, while e has more elements. So we need to get string client ID equal e.x element. So we've got the key, and then the way to obtain the thread client, because we can only send the message to through the thread client object. We cannot send the message through the thread server object. This client list dot get client ID. So basically what we need to do is we need to call the send function, which doesn't exist because we haven't created any send function, right? So we have to move this. Let's see, let's move this to here. And then send the message. So here we need to create a new function. Let's call it send. What it is to do is just call the object output trim write object. There you go. And then always flush everything. So like this. So there's no error handling in here. So yeah, this is like the bare minimum of a working chat application. So we created the send method. So it should be able to send the message from the thread server. Wait, hang on. Which one is this? I should have used different name. So this one is for the client side. So yes, it's correct. Hey, hang on. No. This is not correct. This is supposed to be for the server side. This is the server side, right? No. That's the server side. Sorry. Okay, let's see the package. Okay, that's correct. Okay, it seems okay. Now let's modify the main function a bit. Where's the chat server? This one. So instead of these lines, I'm just gonna create a new thread server and then let it start. Okay, I think we're done. Now let's see. This is where's the chat server? I'm gonna run this. Okay, I assume it's running. And then where's the chat client? Okay, I'm just gonna run 3 of these. How do I run another one? Test. Hello. Okay, we need to debug some stuff. And how do we chat client? How do I start another instance? Hang on, I can't see clearly from. Okay. Okay, it still doesn't appear. Okay, now let's debug this. Let's stop everything first. Chat client. Okay, just gonna print this here. Oh, I know what's the problem. We made a mistake in here. I didn't use system.out, but I used system.error. Out. Okay. Thing we're good to go now. Let's start this thing again. Okay, the client start. Where's the chat client? Run project. Let's start with Aaron and then oops, actual state. Okay, let's run another chat client.java. Let's put Levi. Let's say hello. Okay, it still doesn't appear. Hang on. Let's stop everything and debug. Okay, let's I'll just move this to my screen. If you want, you can also find out what's wrong. Ah, what stupid. Okay, has anyone noticed the mistake I made? Exactly. What an idiot. Yeah, so we need to start the thread client first, somewhere over here. Because we just made the client. So we just created the class, but we haven't instantiated. New thread client, we need the object input stream as the parameter. So we need to create a new object input stream that we get from the socket get input stream. And don't forget to start it. There you go. Now let's see. Hang on, did I stop it? The previous one. Okay. Let's stop everything. I'm gonna start the server now. I'm gonna start the client. Okay, I'm just gonna see we have our own message, and let's see if I'm just gonna start another client and another one. Hang on. Okay, so now we have 3 clients in total. I have Aaron, Levi, and Mikasa. Let's send hello from Mikasa. And then as you can see, we have the message. We received the message, hello, hello, and so on. So that's how you create a chat-based, if this is how you create a chat application that allows you to send a broadcast message. Any question? Maybe we've running out of time. No? Yeah. Hang on, before you sharing your screen, I'm gonna announce the assignment first. So basically, as I said, you need to develop an instant messaging or a chat application. There are several features that you need to implement. First, the messages are exchanged as Java objects. So you need to use the object serialization. Users can log into the system. Users can also see other online users. So you have the list of online users. Users can also send private messages, because I just show you how to create a chat application that can send broadcast messages. And the last one is optional. So if you want, you can use SSL socket for communication. Basically, you just need to replace 2 lines of code, and then you get an extra point. Because there's no difference at all. Okay, any question maybe about the assignment? Okay, if not, maybe I'll end the meeting today. And Vishnu, if you still wanna solve the problem, you can stay here for a while, because maybe the others need to go to another class. Okay, thank you everyone. I'm just gonna stop the recording.
Recording stopped.
Right.
About the user agency and online users. Is it one or first it only shows them connected
Jadi ini cuman yang penting bisa melihat user yang online itu namanya siapa saja.
kalau misalnya ada user online itu apakah langsung muncul dunia online atau harus ada interaksi dulu?
Langsung muncul. Sebenarnya tergantung dari aplikasi kalian sih. Kalau aplikasinya itu pakai GUI, kan biasanya ada apa namanya, ada kolom untuk daftar user. Nah itu kalau seperti itu bisa langsung otomatis update. Tapi kalau misalkan kalian pakai command line, kan nggak mungkin tuh langsung update. Nah kalau seperti itu bisa langsung misalkan minta ke server yang online siapa saja gitu juga boleh. Yang penting ada fitur untuk melihat siapa saja user yang sedang online. Ya. Ya. Kalau tadi kan saya langsung ngirim username bersamaan dengan message-nya kan. Seharusnya kan ada proses ngirim username dulu. Nanti detailnya juga akan saya taruh di Classroom ya. Biasanya yang di Classroom itu yang lebih detail daripada ini. Jadi jangan lupa dibaca yang di Classroom. Oke, terima kasih. Saya akhiri meetingnya. Selamat siang.